Okay, welcome. If you're joining remotely, this is the Denver, Erlang, and Elixir meetup for Monday, June 3rd, 2024. My name is Michael Lubis. I'm the organizer tonight. The meetup is sponsored by Praxis.io, which helps developers secure their web applications. So if you're using Elixir, the support from Praxis.io is really excellent. Please take a look. So for the main event, Paulo is speaking tonight. I actually met Paulo a few years ago. I think it was a code beam at the speakers dinner. He is part of several teams related to Elixir.
Whole desktop. So
Yep,
can
that's
you
working.
guys? Okay.
Nice.
I'm using a dual monitor setup, so hopefully things are not getting screwed up.
Yeah, looks good.
Okay, so as Michael mentioned, I'm part of the NX team as well as the gRPC team, which is now a team actually. It had been just me for a few months, you can say, and now we have Dave Lucia and Adriano, who is another Brazilian developer. I'm from Brazil, I live in Rio. And today I'm going to talk about how we can add an AI feature to a given Phoenix LiveView app. And for that, we're going to use Bumblebee, and we're going to look into an image classification model, just so we can get a feeling on how we can deal with situations where we have lots of data being transferred between the client and the server, because generally AI applications run on the server side. So is the font size okay?
Yeah, this looks good.
Okay. So first, we just need to set up a Phoenix LiveView application. I have this already set up on VS Code, so I'll be switching back and forth so we can look into specific parts of the code as well. And we're going to use the STB image dependency just so we can load the image binary into something that Bumblebee can use. Bumblebee is one of the NX ecosystem libraries. Let me open Hexdoc so we can take a look. And yeah, Bumblebee is built upon Axon, which is the NX library for neural networks. And it basically is a way for us to load models from Hugging Face. So lots and lots of pre-trained models that are already supported. And here's on the sidebar, we can see a brief list of those. And Bumblebee lets you download a model and load it in such a way that it can be loaded as an NX serving, which is one of the main features that we're going to look into from NX. So after we set up our dependencies, we also need to configure NX so that we have a default backend and the correct compiler setup with EXLA. EXLA uses the XLA library underneath, which is the same accelerator that TensorFlow uses, as well as JAX from Python. And a backend in NX means that we're using a specific implementation. NX works with works on a specific interface, which is the NX backend behavior. And this interface can be implemented in various different ways. And EXLA implements one that can be used in conjunction with the EXLA compiler to build computational graphs that can then be compiled at runtime for the specific device that you're running. So it's a lot faster than, say, using the default backend, which is the NX binary backend. So as I had mentioned, we're going to use an image classification feature. So we're going to use the image classification. We're going to add a new route called image classification to our router. And this route is going to be handled by a LiveView. And this LiveView is just gonna do a few things. It's gonna start up a webcam hook. For those familiar with LiveView hooks, it's just a way for us to use JavaScript and send things to the server periodically in this case. Basically, this is how we capture the webcam. And it's gonna send frames to the server that can then be classified. And then we're gonna display the results. So let me open the server. So yeah, actually was already open. So as you can see, it's already recognizing my microphone. We can put a cup in front of the camera, and we're gonna see that it recognizes a coffee mug. So we have a working model. And we can also see that we're measuring, sorry, misclick. We can also see that we're measuring the bandwidth consumed, and we're gonna get back to this. So this is just the layout for that page. Nothing really magical here. If you know LiveView, you can do this in like 5 minutes. And here is the event handling function that receives a base64 encoded image, decodes it, and then reads it as an STB image data structure that can then be passed into the NX serving. So the NX serving is a way for us to have a function that takes in data or batches of data and can work in such a way that, for instance, let's say we have 10 clients connected to our server. Ideally, we would process their requests at the same time on the GPU, for instance. And if we just use a naive approach, those requests will be processed in sequence, basically, because the GPU will be logged for each one. So that's not good. But NX serving allows us to batch all of the requests together without having that complexity on the calling side. So we're just passing an image here, but NX serving underneath will batch different requests from different processes into a specific batch that is processed as a single unit, and then it unbatches the results. So each process that made a request can get their specific results back. So with just this single line, we're already using NX's distribution power to handle concurrency much better than just a simple defn call, let's say. And this is just formatting the results so we can present them better and then assign them to the socket. And this is also where we measure how much data we're actually transferring. On the router, it's just a simple LiveView declaration. And here's the initial version of the hook. We're gonna work on this as well. But basically this hook is setting a target frame per second ratio that we're using to transfer the data to the server. And for this example, 1 FPS is fine. One image per second is more than fine. And this is how we get the video from the camera. So here we make the camera instance. We get the camera instance actually, and then add a timeout so that each, in this case, 1000 milliseconds, we capture the current frame. And this is how we get the image data as a base64 encoded data structure that we can then pass to the server. So with all of these pieces together, we already have the code running basically. And this is just connecting this hook to LiveView. So also let me show you the application tree. So let me zoom a little bit more. Okay, is this font size okay?
Yeah.
Okay. With just these 3 lines plus this one, we have already set up everything that we need from NX. So these 2 lines will download the metadata for the model and the actual model weights. If we're talking about AI, in general, we have model weights, which are just the numbers, the parameters that capture the actual AI, how the AI learned given a specific topology for the neural network, let's say. So load model will basically give us the topology, and load featurizer will give us the weights. This is a kind of huge download, a few gigabytes, but it only downloads on the first time. If you run it again, it will get it from the local cache. So these 2 lines get our model, and with these 2 inputs, we can then build an image classification serving using the Bumblebee vision model. This serving is then passed into the NX serving child spec. And here is what I was talking about, where we have a batch size of 10. So let's say we have 8 concurrent users. They're all going to be processed on the same batch, but we also have a timeout. So if 2 other users join before 100 milliseconds have passed, they're also going to get into that same batch. Otherwise, they're going to be allocated to the next batch while this one processes the data. Kind of like Broadway, if you're familiar with it. And this name is just a process registry name that we can then refer to, kind of like named gen servers. So this is the magical line, and we're also going to play with it in a few minutes when we get towards the end of the talk. But before we get to that, let's go back to this number, average data rate. This is basically saying that even if we're just processing 1 frame per second, I'm still consuming half a megabyte of data per second from a single user. This gets pretty expensive to process on the server side, but also gets expensive to the user because since the beginning of the talk, I have already consumed like hundreds and hundreds of megabytes, and this on a mobile network is just not good. So what can we do about this? The ResNet model that we're using, this model here, it takes in images that are 144 pixels by 144 pixels. Not big images, but we're making an instance we're making a webcam instance that's 640 by 480, which is a rather standard size. But we can work on that to reduce, oh, sorry, it's 244, not 144. We can work on that so that our input is resized on the client so that we transfer less data in exchange of a few cycles of processing power on the client side. So this is basically the same code as before, but we have this resizing call where we're just scaling things so that we have a width of 244 and a proportional height so we don't distort the image. And after that, we can also compress the image using the Paco library in this case, but we can compress the image so that we take something that has already been reduced by an order of magnitude and compress it even more so we're more efficient about data transfer. And this result is then encoded in base64 so that we can send it to the server. And then we just need to do the correct coding on the server side so that things are still working as expected. Both sides need to obey the same contract. And then image is still something that Bumblebee can use, but let's restart the server here with our new version. And we're gonna see that we're actually consuming like 1 order of magnitude less data. So let me restart. And yeah, instead of 500 kilobytes per second, we're on like 80 kilobytes per second. And that's a lot more efficient. So this is one of the points that I want to drive. Like if you have to take one thing out of this talk, I'd like for you to always think about how much data you're transferring and who's paying for that data. Because if we just do the things in the most straightforward way, we're probably gonna put some, we're gonna probably make the client pay for this one way or the other. So it's really important for us to think about exactly what we need to transfer and how we can transfer it in the most efficient way. And this also would benefit latency because we're transferring fewer bytes. So it's less time between the start of the transfer and the end of the processing on the server side. And NX serving also gives us a new superpower that we can also use in like this setting where we want to add an AI feature to our application, which is distribution. NX serving is distributed by default. So if we just take the application tree and change it up a little bit like this, we can make it so that our feature is running on just a single node, which will be more expensive and should probably be dealing with just really specific requests. So let's say a GPU node. In this case, it's not a GPU node, not yet at least, because we're actually working on supporting Mac GPUs. But let's say we have a GPU node and a few web nodes. We can just start the NX serving on the GPU node. We cannot start it on the web nodes, and without changing the LiveView, we're actually gonna call the GPU node from the web nodes. And I'm gonna demonstrate that right now. This application getM call is just basically me reading from, wait a second. Yeah, so where is it? Yeah, so I've added this system envor that I can use to control which node is gonna have the camera serving. So I have this line already saved. I'm gonna start the GPU node, or actually a node named GPU within the camera serving and a specific cookie. And the same line for the web node, but without the camera serving. So if I just start this and then go to the web page, we're gonna see errors because it basically NX can't find the next serving yet. Okay, so we can connect the two nodes, and this can be done automatically with, let's say, libcluster. But in this case, I'm doing it manually just because we can. We're just connecting two nodes. And now we don't have errors anymore. And this is where the magic happens, because now the web node is actually calling this node. The next serving on this node is what is actually processing the data. And we can prove that by dropping this node again, and we'll see that errors start popping up again. So, and NX serving also does load balancing. So if you have more than one node, it will basically do a round robin. You can do like a weighted round robin as well, but that's probably for another talk. I'm not sure if that was too fast. We can get in more details if you guys want, but this is what I had for today. Thank you.
Awesome, dude. Thank you so much.